There are a ton of valid server-side UI options, but sometimes JavaScript is just necessary. Maybe you're displaying a map, or you want to use a specific UI library. But once you go down this path, data access can become complicated. All of a sudden, you're designing an API and building out a client library to access it. Or maybe you end up having to settle for a Node backend. Today, I'm here to show you a brand new library that's genuinely refreshing: Ash TypeScript. In case you're not familiar, Ash is an Elixir framework that takes a declarative approach to data and behavior modeling. In today's example app, code available on GitHub with a link in the description, we'll list through publicly traded companies using a dataset from the SEC. Let's see what that dataset looks like. Okay, companies have properties like name, ticker, and exchange. And in today's project, you can scroll through a paginated virtual list of these companies. And the patterns established in this video can scale to much larger, much more complex projects. Now, Ash is typically used in Phoenix apps, which is where today's project really starts. You see, in Phoenix apps, it's common to use a LiveView to bring interactivity. Behind the scenes, it sends HTML templates over a WebSocket and shoves them into the page. Let me show you what that looks like. So this is a LiveView version of what we're going to be building today. And when I scroll to the bottom, take a look at the WebSocket and how it's sending us data every time we reach the bottom of the page. This data itself is a bunch of HTML diffs. And it's actually really easy to build this in LiveView, but eventually the page slows down. But with Ash TypeScript, it's possible to automatically generate an RPC client that can access all of the actions on Ash resources: filtering, pagination, access control, all without much fuss. From this generated code, it's easy to drop into any front-end framework with type annotations to guide the way. But that's enough chit-chat, let's get to building. First, I'm going to create a new Phoenix project, and I'm going to do it from the Ash homepage. We'll start out without TypeScript for now, and I'll show you how to add it later on. Hopefully that'll help folks with existing apps migrate some of their stuff over. So we're going to call the project Stock Explorer, and it's going to be a Phoenix LiveView app where we're integrating with Phoenix and using SQLite as a database. It just seemed pretty portable. You can always change this yourself. And that gives me these commands, which I can copy, and then I can paste them into my terminal. And this will create the Stock Explorer directory. It'll create all of the scaffolding for the Phoenix app and then add the Ash layer on top of it. And after a few moments of compiling, I can now cd into Stock Explorer and open it in my editor. And in my editor, just like any other Phoenix project, I can start the server with iex-s mix phoenix.server. And if everything went correctly, I can hit localhost 4000 and get the base Phoenix template. Now let's go back to the dataset. Like I mentioned earlier, this comes from the US federal government, and they've got some special rules on how to download files programmatically. They have a specific user agent that you have to add. That sounded like too much complexity, so instead, I just grabbed this JSON directly off of the website using my browser, grab it, and I'll drop it into my project. We'll come back to this later, but I'm going to put it in the private directory under reference data, and we'll call this company tickers exchange.json, just like it was on the SEC website. Copy it over, save it, and close it. We'll take a look at that later. But first, let's do our data and action modeling. So Ash projects are made up of resources that live in domains. Not feeling very creative, I'm going to name my domain resources. So over in lib stock explorer, we're going to create resources.ex. In bigger projects, these should be logical domains. Maybe this would be a finance domain, and you'd also have an accounts domain and other areas of your app broken out into these little pockets. But in this project, we're going to def module stockexplorer.resources, and we're going to use ash.domain. This behavior will give us a DSL, which will be important later. Now, this domain needs to be registered in our project configuration so the framework knows that it exists. So over in config.exs, somewhere around line 45, we've got the configuration for our Stock Explorer app. And it says where our database is and some generator settings, and we're going to add Ash domains and paste in the name of our stockexplorer.resources domain. So we have a registered domain, but we don't have any resources. So let's fix that. Over in lib stock explorer, we'll create a resources directory. And in that directory, we'll create exchange.ex. This is going to end up being one of our database models, but it also includes the actions we can take on it. So we're going to go def module, and it's going to be stockexplorer.resources.exchange. We're going to use ash.resource this time, setting the domain to stockexplorer.resources, and the data layer for persistence is going to be ash SQLite.datalayer. Now, over on the SQLite side, we want the table to be called exchanges, and we're going to store this in the stockexplorer.repo repository. This is our database abstraction layer. Now, an exchange is going to be a very simple object. So for its attributes, we want a ID, and we want a name attribute of type string. We'll describe it as the name of the exchange. We don't want any null values, and well, that's about it for that side. And finally, we need to define some actions that we can do on these exchanges. The most simple way to start this is to take the defaults. And we're actually just going to take create and read to keep it extra simple. Now, resources reference their domain, but their domain also has to reference them in return. So going back over to resources.ex, we're going to say that this domain has a resource called stockexplorer.resources.exchange. Now, like it or not, Ash can generate database migrations for your application so you can build quickly. If you come from Django, you know how helpful this could be. So I'll open up my terminal and let's run mix ash.codegen, and we'll give it the name of add exchanges. This is going to be the name of the migration that we're generating. Behind the scenes, it's taking a look at all the structures, and it has produced a migration file called addexchanges.ex. This simply defines that there's going to be a table called exchanges, and its primary key is going to be a UUID, and it also has a name column that is of type text and cannot be null. And then if we're going in reverse, we want to drop that table. So if you're familiar with Phoenix apps, you probably know about context modules, and if you don't, I'll explain them. Inspired by domain-driven design, these are the interface between your application code, your business logic, and the persistence layer. In Ash, domains serve a similar purpose, but with a little bit more power. Our exchange resource has a read and a create action. And one cool thing that we can do with domains in Ash is define a code interface that lets us, instead of directly knowing the resource behind the scenes, talk to this domain module. So we can define that there is a function called create exchange, and it's going to be a proxy to the create action on the exchange resource. Then over in any Elixir context, we can run stockexplorer.resources, and I'll do dot and hit tab to show what options we have here. And it actually looks like I skipped a step here. We created the migrations, but we never ran them. Luckily, there's this really convenient button here, and we've got an error message to say run the migrations. That's going to create the table that we forgot to create. Okay, so now in any Elixir context, we can run stockexplorer.resources. And I'll hit tab here to show what options exist. We've got some methods called can create exchange, and then we've got create exchange itself with a bang variant with different options in there. A whole bunch of functionality just got unlocked by that one line of code defining this interface. So I want to create an exchange. And well, it looks like I got an error. The name attribute is required. That makes perfect sense. So let's replace this with a call that includes a name argument of CAS, code and stuff. Now, when I try and run this with the name property, it's going to say that you can't access this name property The reason for that is that the default create action only considers what are public attributes. That's a concept that we'll get into later, but for now, let's just make the name attribute public, recompile, and now we should be able to create that exchange, and there it is with an ID. It's been placed in the database. If you don't believe me, we can open that up in SQLite and select star from exchanges. And there it is, CAS and that ID. So we've got a create method, but I want exchange records to be globally unique. I don't want there to be more than one New York Stock Exchange. In Ash, the tool for uniqueness is called identities. Let me show you what they look like in the documentation. So you can declare that a record is uniquely identified by one or more attributes. Maybe you want a unique email address or a unique username per site or whatever that is in your application. Well, it looks easy enough, so let's add that to the Exchange resource. We'll add an identities block, and we'll say identity unique name, and we want this to be on the name attribute. Now we can run our code gen again, and this time we'll add exchange name identity and mix ash.migrate to migrate the database to that new version, which internally just has a new unique index on name. Now, to get what we're looking for, we're going to have to bail out of the default create action and instead define our own. So in actions, I'm going to remove the create action and instead set up my own. So I want to create, and we'll still call it create. We want to accept names, and we want this to be an upsert action. That is, we want to use the existing object if we can, and create one if none is found. And we want the upsert identity to be unique name. That is, on conflict in the name identity, we want this to be an update operation instead of a create. And finally, we want to set this to be the primary action. That way, anytime that we create an exchange, by default, anywhere in the Ash framework, we are going to get these upsert semantics. Now, if I run that create exchange command again, I'll get the exact same exchange resource every single time, the same UUID, the same record from the database. Now that is a pretty valuable thing in what is a pretty small amount of code, to be honest. All right, we're going to need one more resource in this project, and then we'll get to the actual implementation and finally migrate it over to Ash TypeScript. So we're going to need to keep track of companies. Unsurprisingly, this will be another resource. We'll put this in lib stock explorer resources in a file called company.ex. We'll define a module, use ash.resource, put this in the stock explorer.resources domain with a data layer of Ash SQLite. For SQLite, we want the table to be called companies and the repo to be stockexplorer.repo. Companies are going to have a few more attributes, but I'm going to paste this in because it's kind of the same thing as what we did for Exchange. We've got an ID, we've got the central index key integer, we've got the name of the company, and we've got a ticker symbol. This central index key thing is the ID that you could use to correlate to other filing data if you wanted to take this project further and scrape more of the SEC's open data set. Now, companies are listed on an exchange, which we will represent as a belongs to relationship. So under relationships, we'll say that this belongs to an exchange, which is going to be a stockexplorer.resources.exchange. And for actions, let's start out with a default read action, but we're going to just jump right into a custom create. The create is going to be named create, and it's going to accept the CIK name and ticker, not ticket, attributes. And then when we create one of these, let's also make sure that the exchange exists for them. To do that, I'm going to add an argument called exchange, which is going to be of type map. And then when we run this action, we're going to do an additional change, which is to manage our relationship to an exchange. Specifically, we want to create an exchange if it doesn't exist. Now, behind the scenes, this is going to find whatever is the primary create action on that resource, which, like we established earlier, is going to have upsert semantics. So when we create a company, we'll pass an object under the exchange key, which in turn will be processed by the exchange resource. Let's add this to the domain and to the code interface. Over in resources, let's say that there is a company resource which can be created and can be listed. But before we do any of that, we need to have this in the database. So let's do some code gen, and we're going to add companies. And we will migrate it. Add companies, unsurprisingly, has an exchange ID that references the ID from the exchanges table, and then it has ticker, name, CIK, and ID. And with all of that in place, if I recompile, I should be able to create a company. We will create testco with a CIK of 12345, a ticker value of test, and it's going to be on our existing CAS exchange. That's code and stuff. Now, you're going to have to trust me on this. This is the same UUID. We created this company on that exchange. If I go over to SQLite, we can see that we have a companies and an exchanges table. And if we select from companies, we've got all of that data, and it's referencing the exchanges. But if I left out this exchange part, what would happen? I mean, I didn't specify any sort of validation that needs to occur. I just said that this is a map. We didn't say that this is required, so it would actually go through and create a company that's not associated with an exchange. And that's not great. So let's make that property required by saying allow nil false on the exchange map. So if I run this without specifying an exchange, then it's going to say, hey, an exchange is required. And of course, if I say that we have an exchange that is an empty object, it's going to say that the name property of the exchange is required. We get all of these nice change set validations behind the scenes for us because we are declaring the properties and the attributes and the requirements in a domain-specific language. All right, so we've got our data layer defined. Let's load the data from that source file that we put over in reference data. Again, you could use a library to pull that data down dynamically. Just make sure that you follow the SEC requirements. But in this case, I've already got the data file in my project. So when you initialize a Phoenix project, it will run a script called seeds.exs, which is inside of our project right now and doesn't do anything. But it's intended for you to be able to insert data into the database when you start the project up. So I'm going to paste in an implementation and we can walk through what it's going to do. Let's get rid of that terminal. So we are going to grab the company tickers exchange.json file from the private directory of our application. After doing that, we're going to open up the file and pass it to the native json.decode function. Now, this JSON module was added to Elixir a few versions back, and I made a video about it. But if you're using an older version, then you might want to use a package like JSON to pull in that JSON data. And if you are running a modern version, don't worry about it. We've already got JSON built in now. Now, when I was looking through the data file, I saw that some companies don't have an exchange listed. This results in a null value, and I want to translate null values into unknown, but every other record, let's just keep it as is. Then finally, let's pass that into create company and construct these objects just like what we had when we were manually inserting companies through IEX. Internally, the framework is batching writes for us. Everything here is configurable, but there are some sane defaults here. So if I run mix ecto.setup, the seeds file is going to run, and we're going to insert all of that data. And it went pretty quickly. And we can confirm that that data was inserted by running a query. We will call stockexplorer.resources.listCompanies. Again, something that was defined right here in our code interface. And in the query, let's just limit it to 1. I don't want to get overwhelmed. And here is Testco. Actually, let's grab 2 of them to make sure we've got another one. Oh, there's NVIDIA. I hope their stock's going up. And, well, exchange is a not loaded value. And while we've got the ID, I'd love to see the name of the exchange that NVIDIA is trading on. Now, you probably already knew this, but let's find it in the database. By saying, when we pull this data, let's also load the name of the exchange. And they trade on NASDAQ. All right, so we've got all of this data in the database. We have an interface for creating things. We're doing upserts, all very fancy stuff. Let's work on a UI to actually explore this data. Like I said earlier, it's common in Phoenix apps to use LiveView. It's a great starting point, and it can be enough for many apps. If you want to know more about LiveView, I've got an entire series and several standalone videos on the topic. So let's create a LiveView under lib Stock Explorer Web live, and we'll call this companieslive.ex. This is going to be a module that uses Stock Explorer Web, specifically LiveView. Our mount function is going to load some companies, and to load companies, we're going to take the socket and then assign the companies attribute to the result of list companies, making sure that we load the exchange, and by default, exchange is going to include a name. Then, when this component renders, we're going to have this HTML template. So it's going to be inside of our app layout. This is new from the latest version of Phoenix. We're going to have a div that's a container, and we're going to loop through all of the companies in our state, rendering out the ticker, the name, and the exchange name, and this central index key. Now, this is incredibly naive and actually pretty terrible as the dataset gets larger. And technically, this doesn't even need to be a live view. We're just rendering some HTML, a lot of HTML. When I measured this earlier, this page was using nearly a gig of RAM and would easily crash some lower end computers or mobile devices. Now, let's take a look at it by registering it in our router. So we're going to say that we have a live view. We'll call it companies live view, and this is going to be companies live. So if I go over to my web browser and go to /companies live view, sure enough, there's the entire data set. It's fine for a prototype, but it definitely needs to be optimized. Oh, and since it's a live view, it also keeps the entire set in memory on the corresponding server process. So if you have a bunch of users accessing this page, your server's probably going to blow up. So to reduce the server memory, Phoenix Live View has an optimization called streams. Basically, we get rid of our server copy of the items once we send them to the client. Opting into streams involves going into the live view and, well, let's restructure this. So we're going to redefine socket to be socket piped into a function called stream, where we define a company stream that defaults to an empty array. And then we're going to pipe that into our load companies function. Then in load companies, instead of assigning companies, we are going to stream companies, setting it to this company's value, and it'll only be in memory while we're rendering, and then it'll drop off. Now over in our for loop, we have to change this into a slightly different construction. Instead of at companies, this comes from at streams.companies. And this is actually a tuple value with an ID and then the company. Then we need to set an ID, and we'll set it to this ID value that we get off of the stream. And then finally, in the parent, we need to say phx update equals stream. What this means is that instead of replacing the repeated elements inside of this container, which is the default of the Phoenix framework, we are going to treat this as a stream, looking for those ID properties and intelligently inserting or updating those values. That way, if something with the same ID ends up running through as an update, then the table is going to just be updated in that single row. So set Phoenix update to stream, switch over to streams as your assign, use a tuple to grab the ID and set the ID over here. Now, if I load this page, it's going to take just as long to load, and it's going to have just as many elements on the page, but the server is under slightly less pressure. Now, this works, but it's kind of missing the point. Unless we very aggressively scroll, we're probably not going to get very far in the list. So let's add pagination and only scoop up a few companies at a time. I'll also point out, this is somewhere that Ash really shines. Typically, pagination requires a lot of effort in a context module to get right. But in Ash, pagination is something built in, either offset or key set pagination. And here's some examples. So let's update our companies resource to be paginated. Because we're ready to do something more than the default, let's replace this read with a new read. We want it to be the primary, and let's make sure that we have a stable sort order by sorting on the ticker value. And then for pagination, let's say that we want key set pagination, and for safety, let's set a max page size of 50. And to be extra safe, let's say that pagination is always required. Key set pagination is more performant than limit offset based, but offset is available if that's what you're looking for. But if we're going to be sorting on this field, we probably are going to want a database index on it. So let's come up here and say that we want a custom index on the ticker property. Over in our Ash code gen, let's say add companies ticker index. And the migration is going to create an index on companies on the ticker property. We'll migrate it, and we are ready for key set pagination. Now, unsurprisingly, Ash pagination uses an attribute called page, which internally can have a limit or some other properties. And it returns a key set, which has results, and then it may have a count, it'll have what is the limit, a function for rerunning, and whether there is more data. All of these are really valuable attributes, so let's wire it up. Over in our LiveView, up in the mount function, let's add a couple of new properties. Let's say after key set, this is going to be our next pointer. Set that to nil. And then let's also say a Boolean called end of list, and we'll set that to false by default. Now, our load companies implementation is going to get a little bit more complicated, and I'm going to paste this one in and we can walk through it. So on this page, even though our hard limit is 50 companies, let's set the limit to 25. It'll visually flow a little bit better. Now for our page options, if we know that we have a next page pointer, let's put that into our page options so that we'll say limit 25 after some certain value that we saw before. Then we'll pass those page options into the function, and when we get our results, we can set companies to that result. And we can also determine through this Boolean more whether we're at the end of the list. And to grab the after value off of the last company, we have to do this through metadata. This is just something that you can copy and paste from the documentation. It's always there when you're doing key set pagination in Ash. Now, to tie the LiveView version together, we also need to have a way of requesting more data. Because right now, we're just loading one page and that's it. 25 companies, not a great experience. But they are sorted by the ticker, so we'll give ourselves that. Phoenix LiveView has something pretty neat built in for this infinite scrolling scenario because it's so common. So if I set Phoenix viewport bottom to a string value, then an action called load more, in this case, will be invoked whenever we get to the bottom of this container. In fact, if I open up my server logs and scroll to the bottom here, we'll see that we crash because we got one of those events and we didn't have a handler for it. Handle event load more doesn't exist. So let's fix that by adding that function. So load more, if we are at the end of the list, is going to do nothing. It's just going to return the socket. But if we aren't at the end of the list, then we're going to call load companies, which will in turn load another page. And now our LiveView implementation is complete. When I scroll to the bottom of the list, more data is fetched indefinitely. The server only holds on to one page of data at a time, but in the end, the browser still has all of these divs in memory. Thinking back to when React was originally released, it was built to address this issue with the virtual DOM. The theory was that it's a lot easier to manipulate JavaScript objects than to manipulate divs and other elements in the actual DOM itself. So let's do it in React. And before you get upset, it doesn't have to be React. It could be Vue or Svelte, anything really. It's just that React is pretty common these days. Setting up a React spa within a Phoenix project takes a few steps, and I found this out while I was finishing the script. It turns out there's a React setup option right inside of the Ash website. So if you don't want to do this by hand, you can skip this section, but I think it's interesting to know all of the moving pieces. Also, it's just a testament to how fast things are moving on this package and in this space. So over in the project, let's run npm install with a prefix of assets, and we're going to save the React and React DOM packages. Now, this assets prefix is important because this is where all of the JavaScript and CSS inside of a Phoenix project live. If we have everything in the assets directory, then it will bundle and serve properly under the default configuration. And you can override all of this. This is just the way that works with every Phoenix project. Now, to serve this as a single page app, let's go into our router and set the React prefix with any sort of path after it to run the React action on our page controller. Over in the page controller, we can say React is going to render a template called React. And the template itself is going to be under page HTML, react.html.heeks. I'll paste in an implementation that is going to have a single div called app, and it's going to pull in a static bundle called react.js from our JS assets directory. Now, to create that file, I'm going to add react.tsx, and let's just have a little hello React, hello world. So we're going to pull in React and React DOM client, mount this app element, and say hello React. Now, this little error that we can't use JSX is a good hint that our TypeScript compiler is not set up properly. Over in tsconfig, I'm going to add a couple of other compiler options. We want JSX to be in the React style. We want ES module interop, and we want to have DOM interactions, plus all of the latest and greatest ECMAScript features. And now, let's make sure that this entry point gets bundled. So over in config.exs, there is a configuration for ES build where we set our entry point to app.js, and we're just going to add react.tsx as another entry point. That was a lot of steps in a row, I know, but if I restart the web server and go to localhost 4000/react, we get hello React, and I can also add something else. We're still going to get this React template. From this point on, we can develop our React app within the JS directory without any fuss. Now it's time to show off the new Ash TypeScript library. Like many things in Ash, it can be installed via mix-igniter.install with the name of the package, in this case, Ash_TypeScript. It says that it wants to add the dependency to our project. Okay. And it wants to add a controller and some routes for the RPCs that it uses behind the scenes to interact with our data model. Sounds great to me. And that controller itself just proxies into ashtypescript.rpc in case you were curious. So the ash codegen command we've been using to generate migrations now is able to also generate our TypeScript interface. So after running this, there's a new file in our JavaScript assets folder called ashrpc.ts. And internally, it has some utility types, and it has all of this boilerplate that will allow us to have well-typed interfaces to our backend. The only problem is this doesn't do anything yet. Some Ash actions might be intended for internal usage, like maybe we don't want people to be able to create exchanges or create companies through our RPCs. So they aren't exposed by default. Let's fix that by adding the read companies from our domain module. So in stockexplorer.resources, we're going to register the extension ashtypescript.rpc. This gives us a new domain-specific language called TypeScript RPC, where we can say that the resource stockexplorer.resources.company has an RPC action called list companies, and internally that's going to call read. This line is pretty similar to this line down here. The only difference is it's saying what we can do from TypeScript. So if I rerun our code gen and go into ashrpc.ts, look for list companies, we now have types generated for list companies, and we have an async function that's exported that lets us grab this company data. So let's use this in a very naive React component and pull in just a single company. So over in react.tsx, let's just call list companies. It's going to import from ashrpc. And inside of this method, let's say that we want our fields to include ID is the only field that it's letting me select. This is where that public thing comes in again. Remember that Ash considers all fields private and backend only by default. Better safe than sorry. So if I go over to company.ex and make all of our attributes public, and rerun the code gen, then over in my React code, I should be able to see ID as well as CIK, name, and ticker. Now, since this is more about Elixir and Ash than React, I'm going to paste in a component implementation that we will break down. So pasting this in, we've got our same top part here. We're creating a root on that app element, and then we've got a demo component. This component is going to have a single company in state, which by default is null. Using an effect, we are going to list companies, grabbing ID, name, and CIK, limiting 1 on the pages, and if it's a success, we're going to set the company. If we don't have a company, hopefully we're loading, but it might have been an error. Again, this isn't the best React code yet. And if we have a company, let's show its name and its CIK value. Then down in our root, we're just going to render that demo component. Now, if we run this code, we're going to get a 403 forbidden error. And this is because there's a security thing built into Phoenix called CSRF protection, or cross-site request forgery protection. The Ash TypeScript library maintainers have already thought of this, and if we pass headers equal to build CSRF headers into our requests, we should be able to get the first company from our table, which now is this company here. Now, I love that the types are deep enough that my editor knows which values are available on the fields option, but this is where one of the limitations in Ash TypeScript today comes in. Technically, it's possible to load values across associations. For example, if I wanted to grab the name of the company's exchange, I could add this object here and say that I want to load the exchange.name property. TypeScript won't be happy with this, but the RPC itself is more than happy to take this object and this array and give us the value back. Now we can see that this company trades on the New York Stock Exchange. So if I wanted to now, I could say company.exchange.name, and there's your New York Stock Exchange. I'm sure this is going to be made better in the long run. Just know that there are still some rough edges with a library that's this young. The good news is that the functionality is already there, and it's built on top of Ash's entire ecosystem. Also, to make this work, I did have to say that the relationship between a company and its exchange is public. Otherwise, it's going to say that exchange isn't a property. Ash is very defensive by default. Now, at this point, you should be able to build out whatever the heck you need in a React app. But I want to reach feature parity with the LiveView we built earlier. In React, it's common for apps to use the fantastic TanStack Query and Table and Virtual libraries to load and interact with datasets. It's much better than a hacky, fragile use effect. So let's install React Query and get going. So we're going to pull in React Query and React Table as dependencies in our project. And for good measure, for later, let's also add Virtual. Now, an infinite scrolling table like we have in LiveView might be built like this. Let's add companies table.tsx, and let's paste in this implementation. Again, all of this is available on GitHub, so don't worry about all of the lines here. Just know that this is using a library called React Query. And actually, let's walk through some of the code. So we're using Infinite Query, which is a hook available in TanStack Query that lets us automatically do things with pagination scenarios. It's built for infinite scrolling. Now, this hook does an excellent job exposing helpers like fetch next page, has next page, is loading, is fetching next page, errors, all of that stuff. There's a reason that this is the library that people go to. But in its core, all that we're doing is we are running a query function that has the after parameter from our list companies results, and the heavy lifting is being done by this generated code. Then to determine if we have a next page, we're just looking at the has more property and the next page property and returning all of those results on the page. To do our infinite scrolling, we're using an intersection observer, which is something built into the browser that determines if two DOM elements interact with each other. And whenever this thing fires off, if it's intersecting, we have another page and we're not currently loading another page, let's fetch one. And this just comes in from our use infinite query hook up above. So let's get rid of this demo right here and instead render a companies table from our companies table file. And actually, I did miss out on a couple of things. So let's paste in a full implementation and walk through it. TanStack Query does require that you have a query client. This is where the caching occurs, and that has to be injected through a provider. I also added some top level layout stuff just to make this look a bit more similar to the original. Now, if I go over to the page, I have this table, and as I scroll through the table, it's going to automatically do pagination super quickly. Each one of these is a call to run with a payload that includes a pagination key, and we get back 25 pieces of data plus a reference to the next page and the previous page if we wanted to go backwards. So we got to feature parity, and now we're dumping a bunch of things in the DOM. But we can go a little bit further with optimization since we're using React. There's another TanStack package that plays really nicely with tables. TanStack Virtual, and specifically the React Virtual package, will make it so that only a subset of a list needs to be in the DOM at once. This means that the browser doesn't need to thrash around as much and lets us keep very high frame rates with low memory utilization. The diff looks something like this. We're going to use references and a virtualizer to make sure that we have 5 additional elements above and below the container that is scrolling on the page. Then, instead of rendering every single element in the rows, we are going to use virtual items. So we're only going to have a few elements in there. And then there's some helpers inside of this hook that help us understand where the element should be so that the scroll bar looks like it's scrolling through an actual list that is really there. And finally, with all of that implemented, we can scroll through the page at a really high frame rate and it will take care of the rest. The memory is very optimized, and actually this is kind of fun to watch. If we take a look at the list, we only have a few elements below the fold. And as we scroll through, we'll only ever have that many elements. So it only goes down to that point. Everything else is fake. But the library is so performant that we can't tell as users. And it's doing the infinite scrolling, so we can see how many we have available. This is one of those things that is really easy to do in React, or at least it is a pattern that you can follow in React. And it's a legitimate advantage instead of using a server pushed approach. I think eliminating the complexity of data access through code gen makes this a very productive stack for cases where LiveView alone just won't do. At the end of the day, Ash TypeScript is still very new, but it's really promising. There are more features than just reading data, including data validation via Zod and write endpoints, authorization, multi-tenancy. I just had to draw the line somewhere for this video. So I encourage you to try out the package, maybe give it a star on GitHub, and leave feedback in the Ash Discord server. This has been Code and Stuff. Thanks for watching.